The use of advanced technologies to track asteroids approaching Earth is becoming an increasingly relevant task in our time. Each year, the scientific community finds more evidence that Earth faces threats from space. But how can we protect our planet from these dangerous celestial bodies? In the past decade, scientists have made significant strides in developing and applying modern methods for observing asteroids. Radio telescopes such as ALMA and space missions such as NASA's DART play a key role in detecting and studying these objects. Thanks to these technologies, we can obtain accurate data on asteroid trajectories, their sizes and compositions, which allows us to develop more effective defense strategies. However, despite significant progress, many questions remain unanswered. What real threat do asteroids pose to our planet? Are modern technologies capable of guaranteeing complete safety? Or do we need to develop new, more advanced methods of protection? The Goldstone Solar System Radar, GSSR, is one of the most powerful and advanced tools used for observing objects in the solar system. Located in California's Mojave Desert, it is part of NASA's Deep Space Network, DSN. The primary purpose of the GSSR is to provide highly accurate radar observations, enabling scientists to study the surface details and internal structures of asteroids, comets, planets, and their moons. A key feature of the GSSR is its ability to emit powerful radio waves that reflect off the surface of the observed object and return to the antenna. Analyzing these reflected signals allows for the creation of high-resolution images and provides data on the shape, rotation, and other physical characteristics of the object. For example, the GSSR has enabled scientists to create detailed maps of the surfaces of the Moon and Mars, and to study the complex structures of asteroids and comets. The GSSR has several key characteristics that make it an indispensable tool in modern astronomy. Firstly, its 70-meter diameter antenna allows for high-resolution observations. Secondly, the radar can operate across a wide range of frequencies, ensuring high sensitivity and measurement accuracy. The use of a phased array antenna allows for rapid direction changes of the emission and scanning of large areas of the sky in search of interesting objects. The application of the GSSR plays a crucial role not only in scientific research, but also in practical tasks related to protecting Earth from potentially hazardous asteroids. For example, using this radar, scientists can accurately determine the orbits of asteroids and predict their trajectories years in advance. This allows for the early identification of objects that might pose a threat to our planet and the development of measures to deflect or destroy them. One notable example of the successful application of the GSSR is the study of asteroid 2005 YU-55, which passed close to Earth in 2011 at a distance of less than 0.85 lunar distances. Using the radar, scientists obtained detailed images of the asteroid's surface and determined its size and shape. This data was invaluable for developing models of the behavior of similar objects and assessing their potential danger. The GSSR is also actively used to study other objects in the solar system. For instance, the radar has provided detailed images of Mercury's surface, helping scientists better understand the geological history of the planet. Numerous observations of comets have been conducted with the GSSR, aiding in the study of their composition and behavior as they approach the Sun. However, despite these achievements, working with the GSSR requires significant effort and resources. Processing and analyzing the data obtained from the radar is a complex and labor-intensive process that requires the participation of highly qualified specialists. Moreover, maintaining and upgrading the equipment requires substantial financial investments. Asteroid 2011. UL-21 is one of the many near-Earth objects that interest scientists due to its potential threat to Earth. Discovered in 2011, this asteroid belongs to the Apollo group, meaning its orbit crosses Earth's orbit. Since its discovery, asteroid 2011 UL-21 has been the subject of numerous studies using advanced technologies such as the Goldstone Solar System Radar. Scientists estimate that 2011 UL-21 has a diameter of about 300 meters. This is a fairly large object that could cause significant destruction if it collided with Earth. In 2023, the asteroid approached our planet at a distance of about 4.2 million kilometers, which is approximately 11 times the distance from Earth to the Moon. Although this distance is quite large, its orbit continues to be closely monitored to predict any possible changes in the future. One of the most significant discoveries related to 2011 UL-21 was the detection of a satellite. This discovery was made using the GSSR, which allowed scientists to obtain detailed images of the asteroid system. The satellite, about 50 meters in diameter, orbits the main body at a distance of approximately 1 kilometer. Studies of objects like 2011 UL-21 are extremely important for understanding the dynamics of near-Earth asteroids and developing strategies to protect our planet. Accurate data on the trajectory, size, and characteristics of these asteroids allows scientists to model possible collision scenarios and develop methods to prevent disasters. For example, information about the satellite can be critically important for calculating the gravitational forces within the asteroid system, which in turn affects its motion. 2011 UL-21 is a valuable object for studying the internal structure of asteroids. Analyzing reflected radar signals provides data on the asteroid's density and composition, which helps better understand the processes of formation and evolution of such objects in the solar system. In the future, monitoring of 2011 UL-21 and other potentially hazardous asteroids is planned to continue using the GSSR and other instruments. Asteroid 2024 MK is yet another near-Earth object that has attracted scientists' attention due to its characteristics and trajectory. Discovered in early 2024, this asteroid has a diameter of about 150 meters and belongs to the Aten group, whose orbits lie mainly within Earth's orbit. The closest approach of asteroid 2024 MK to Earth occurred in June 2024, when it passed at a distance of approximately 3.8 million kilometers, which is equivalent to 10 distances from the Earth to the Moon. Despite the apparent safety of this distance, it still interests scientists because of the possible influence of Earth's gravitational field on the asteroid's orbit. What changes might occur in the future if the asteroid approaches our planet again? Since the discovery of 2024 MK, scientists have been actively observing its motion using the GSSR and other telescopes. These observations allow them not only to precisely determine the current orbit of the asteroid, but also to predict its future trajectories. Thanks to data obtained from GSSR, it has been found that 2024 MK has an unusually elongated orbit with an eccentricity of 0.45, making its behavior unpredictable. The gravitational influence of Earth on objects like 2024 MK can significantly alter their orbits. When passing close to our planet, asteroids can experience strong gravitational perturbations that can change their trajectory. This phenomenon is known as a gravitational maneuver. In the case of 2024 MK, slight changes in its orbit were already recorded after its last close approach to Earth. What further changes will occur, and could this lead to closer approaches in the future? These questions require ongoing research and observation. Given the significant size and speed of the asteroid, continued monitoring is necessary for timely prediction of any potential threats. It is estimated that in the coming decades, 2024 MK could pass at a distance of less than 2 million kilometers from Earth, which requires special attention. Continued observations of 2024 MK and other asteroids remain a priority for the scientific community. The analysis of data obtained from observations of asteroids plays a crucial role in understanding their characteristics and behavior. Modern technologies such as radar, optical, and infrared telescopes provide scientists with a wide range of information about the sizes, orbits, rotation, and composition of these celestial bodies. One of the primary methods for measuring asteroid sizes is radar. The Goldstone Solar System radar, for example, allows for high-resolution imaging, from which the diameter and shape of the asteroid can be calculated. The analysis of reflected signals also helps determine the object's surface, whether it is smooth or covered with craters and mountains. In the case of asteroid 2024 MK, radar data revealed its elongated shape and the presence of large protrusions on its surface. Studying the orbits of asteroids requires precise and continuous observations. The use of multiple telescopes located in different parts of the world allows for recording the position of the asteroid at different times and constructing its orbital trajectory. Data on asteroid movements, such as speed and direction, are analyzed using complex mathematical models, enabling predictions of their future behavior. Thus, scientists can assess the likelihood of a collision with Earth and take measures to prevent potential threats. The rotation of asteroids is another important aspect of their study. Observations in the optical and infrared ranges allow for determining the asteroid's rotation period around its axis. This is achieved by recording changes in the object's brightness, which occur due to uneven light reflection from its surface. Knowing the rotation period helps understand the internal structure and composition of the asteroid and predict its behavior when approaching Earth. The composition of asteroids is determined using spectroscopy. The analysis of the spectrum of light reflected from the asteroid's surface reveals the presence of various chemical elements and minerals. For example, observations of asteroid 2011 UL21 showed the presence of iron and nickel, indicating its metallic nature. A comprehensive analysis of all these data provides a thorough understanding of the characteristics and behavior of asteroids. Modern observation and data processing technologies allow for quickly and accurately obtaining the necessary information, which is critically important for ensuring the safety of our planet. In the future, with the development of new methods and tools, our capabilities in studying and monitoring asteroids will continue to expand, making Earth more protected against cosmic threats. Planetary defense is a set of measures and technologies aimed at preventing the Earth from colliding with hazardous asteroids and comets. The importance of obtaining data on the sizes, orbits, rotation, and composition of asteroids cannot be overstated, as it forms the basis for developing effective strategies to protect our planet. One of the key aspects of planetary defense is the early detection of potentially hazardous objects. According to NASA, more than 25,000 near-Earth objects, NEOs, have already been discovered, of which about 2,000 are classified as potentially hazardous asteroids, PHAs. Accurate data on asteroid orbits is critically important for predicting their trajectories and assessing the risk of collision with Earth. For example, data on the movement of the asteroid 2024 MK has made it possible to predict its possible close approaches to our planet in the coming decades. Understanding the rotation of asteroids also plays a significant role in planetary defense. Knowledge of the rotation periods and axial tilts of asteroids helps scientists develop more accurate models of their behavior when interacting with various deflection methods, such as kinetic impact or the use of gravity tractors. If an asteroid has a fast rotation period, it can influence the choice of deflection method, as different parts of the asteroid will respond differently to external forces. The composition of asteroids is important for determining the most effective ways to neutralize them. Asteroids can be rocky, metallic, or consist of a mix of different materials. Spectroscopy data allows scientists to determine which deflection methods will be most effective for a particular asteroid. Metallic asteroids may require different approaches compared to rocky ones. In 2022, NASA's DART, Double Asteroid Redirection Test mission, successfully conducted an experiment to change an asteroid's trajectory by impacting it with a spacecraft. Such experiments demonstrate the real possibility of preventing cosmic threats using modern technologies. Future plans include further development and improvement of planetary defense methods, continuous monitoring of near-Earth objects, and analysis of the obtained data remain priority tasks for the scientific community. The use of advanced technologies and information processing methods will enable timely identification and neutralization of potential threats, ensuring the safety of Earth in the face of cosmic dangers. Future NASA missions and the prospects of further research play a key role in expanding our knowledge of asteroids and improving planetary defense. One of the most anticipated missions is OSIRIS-REx: Origins, Spectral Interpretation, Resource Identification, Security, Regolith Explorer, which has already reached the asteroid Bennu and collected samples from its surface. The return of these samples allows for a detailed study of the asteroid's composition and provides unique information about the early solar system. Another important mission is the NEA Scout, Near-Earth Asteroid Scout, which uses miniature spacecraft to study small near-Earth asteroids. This mission demonstrates the capabilities of CubeSats for conducting deep space research. It is also worth noting the Psyche mission, aimed at exploring the metallic asteroid Psyche. The launch of this mission in 2023 opened new horizons in the study of metallic objects in the solar system. Psyche is one of the largest known metallic asteroids, and its exploration will help to better understand the processes of planetary core formation. Furthermore, NASA actively collaborates with other space agencies, such as the European Space Agency, ESA, and the Japan Aerospace Exploration Agency, JAXA. Joint missions, such as HERA, ESA, and Hayabusa-2, JAXA, are aimed at studying asteroids and developing technologies for planetary defense. The study of asteroids is of immense significance, both for ensuring Earth's safety and for expanding our knowledge of the solar system. Investigating objects such as asteroids 2011, UL-21 and 2024 MK not only helps predict potential threats, but also aids in developing effective methods to protect our planet. With each new discovery, we gain a better understanding of the dynamics and composition of these celestial bodies, which is critically important for developing planetary defense strategies. Modern technologies, such as the Goldstone Solar System radar, GSSR, and spectroscopic methods, provide scientists with precise data on the size, orbits, rotation, and composition of asteroids. This information allows for modeling their behavior, developing deflection and mitigation strategies, and taking timely measures to prevent catastrophic collisions with Earth. Future NASA missions, such as OSIRIS-REx, NEA Scout, DART, and Psyche, along with international cooperation with ESA and JAXA, play a key role in these studies. Each successful research effort and mission brings us closer to more reliable protection of Earth from cosmic threats. Continuous observation and analysis of asteroid data also open new horizons for scientific discoveries. Studying the composition and structure of asteroids helps scientists understand the processes of planetary formation and evolution, as well as explore potential resources for future space missions. It is important to understand that the safety of our planet depends on the continuation and deepening of these studies. Accurate data and modern technologies provide us with the tools to respond timely to possible threats. Subscribe to our channel and follow the news to stay informed about the latest scientific discoveries and achievements in the field of asteroid research and planetary defense.